Ants are strong enough to lift objects many times their own weight, can carry food back to their colony many times their body weight. They are capable of traveling incredibly long distances in search of new food sources, and they can fight to the death against other ants. And still, somehow it's us humans who rule the world. We built huge cities and wage war with nuclear weapons, yet we can't help but step on ants or spray them with pesticides. But maybe we should think twice before doing that. A team of Japanese scientists from Osaka University recently discovered that if you kill one ant, its colony mates will actually become stronger. The more ants you kill, the more powerful the colony becomes. Now, this might sound strange, but there's a good reason behind it. There are over 12,000 known species of ants around the world. But for the most part, they all behave in a similar way. They live in large colonies with thousands of members. Each colony has one queen whose job is to lay eggs. There are also male ants whose job is to mate with the queen. And then there are the workers, which are female ants that have been sterilized by the queen, so she doesn't get any competition. Workers perform all the tasks necessary to keep the colony alive. They defend the nest from intruders, care for the young, forage for food, and serve as human shields, carrying the queen to safety when necessary. But just like any other animal on Earth, ants need food to survive. Depending on the species, they have developed different strategies to obtain it. Some ants are hunters. They chase down their prey, while others are gatherers who collect whatever nature has already prepared for them. Some ants raid the nests of other insects, stealing their eggs and larvae to eat, and some even farm their own food. Leafcutter ants, for example, cut pieces of leaves from nearby plants, carry them back to their nest, and grow fungus gardens on them. Since ants rely on one another for survival, their ability to find food depends on the number of workers available to do the foraging. So if an ant colony has a lot of workers, its chances of finding food are high. On the other hand, if there aren't enough workers, the colony could starve. Scientists believe the Japanese ant colony experiment shows how ant societies strike a balance between risk and reward when it comes to foraging. To make their discovery, the researchers took 360 newly emerged carpenter ants and divided them into 4 groups. One group consisted of 40 ants, and 3 groups consisted of 90 ants. The scientists set up 6 feeding stations around the perimeter of an open field and placed 10 pieces of food at each station. Then they took the ants to a central hub and released them. Half of the ants in each group were given a small piece of sugar water as a reward for bringing food back to the nest. After that, the scientists let the ants go and observed what they did next. As expected, the ants quickly found the food and began to bring it back to the nest. But as soon as one of them returned with food, the scientists removed it from the nest and put it back out in the open field. For the ants that didn't see this happen, it was like nothing had happened. But the ants that witnessed their friends being taken away realized that something was wrong. And this is when things got interesting. In the groups of 90 ants, those who saw their friends taken away refused to leave the nest. This continued until all the food had been brought back and safely stored in the nest. Then they went back to foraging. In the smaller group of 40 ants, though, things played out very differently. When they witnessed their friends being taken away, these ants kept going back out into the field to look for more food. As a result, the 40-ant colony brought back almost double the amount of food as the larger colonies. Now, you might be wondering why the larger groups didn't just match the behavior of the smaller group. After all, if doubling the number of ants doubles the rate at which they can find food, it should also double the rate at which they can lose ants, right? Well, yes, but there's a catch. Every time an ant leaves the nest, it puts itself at risk of being killed. By removing ants from the nest, the researchers increased the risk each individual ant faced. This caused the survivors to act cautiously, which led to less overall food being brought back to the nest. Basically, the Japanese scientists demonstrated that colony size and individual behavior are interconnected. When there are a lot of ants in a colony, individuals are less likely to take risks, because if they die, it won't significantly affect the colony. But when there are fewer ants, individuals must take greater risks because if they die, the colony might collapse. Now here's where things get really interesting. Remember the beginning of the video when I said killing one ant might make its colony stronger? Well, this is it. During the experiment, some of the ants that successfully returned to the nest with food were sacrificed. Even though this reduced the amount of food the colony gained, the surviving ants were more willing to take risks, which led to even more food being brought back to the nest. In fact, in one of the trials, the colony doubled the amount of food it would have collected if no ants had been sacrificed. This means that in situations where there is a lot of risk involved, such as during the first few minutes after finding a new food source, or when an ant colony is under attack, a little bit of sacrifice can go a long way. It gives the remaining ants the boost they need to be more daring, which helps make up for the loss. Now, the scientists haven't figured out yet what exactly causes this effect, but they suspect it has something to do with pheromones. As the scientists write in their paper, ants communicate with each other using chemical signals called pheromones. When an ant finds food, it releases certain pheromones that recruit other ants to come and take some. But when an ant dies, it releases a completely different set of pheromones that tell the other ants to stay away. The dead ant's pheromones might linger near the food source, confusing the ants who come to collect it. So, an ant that returns to the nest without releasing the dead ant's pheromones would appear more trustworthy, convincing its colony mates to take more risks. So the next time you see an ant carrying something many times its own weight, remember it might be trying to save its colony, even if it means giving up its life. Speaking of saving lives, did you know that 700,000 people die each year due to medical errors made in hospitals? But even though this number sounds terrifying, there's no need to worry. It's because there's a new way to avoid the majority of them. The solution is a device called Olive, which can detect and prevent the most common medical errors made by doctors. Olive is a tiny device that attaches to a hospital bed and uses sensors to monitor patients' vital signs, such as heart rate and blood pressure. Olive's AI can then analyze the data to identify any abnormalities and alert doctors in real time. This allows doctors to intervene quickly and prevent potentially life-threatening situations from arising in the first place. What's more, Olive can also remind doctors to perform important tasks that they might otherwise forget, such as checking a patient's blood sugar levels or administering medication. It even has a built-in camera that can detect if a patient has fallen out of bed and notify medical staff immediately. And perhaps the most impressive thing about Olive is its ability to learn and adapt to each patient's unique needs. Over time, Olive's AI algorithms become increasingly accurate at predicting which patients are at risk of medical errors, allowing medical staff to focus their attention on those who need it the most. If you want to learn more about Olive, check the link below. Thank you for watching.